Hello everyone. In the previous lectures, we have briefly go through the operating system, and then we have done some C programming about the operating system. Then we also talk about the process management and the CPU scheduling. Now let's talk about memory management, which is another important component of operating system, and also it is one of the core functionalities provided by operating system. In this chapter, we will cover a number of things. So first, we will briefly talk about the background of memory management. There, we will learn that why memory management is important. We will also talk about some basic concept and the terminologies for the memory management. And then we will also talk about swapping. After that, we will introduce two important memory management schemes. One is continuous memory allocation. The other one is paging. Then we will briefly talk about how to better design the structure of a page table so that it can make the paging mechanism more efficient. First, why memory management is so important? Because a program must get from the disk and load into memory and then place into a process so that the program can be executed in the operating system. And also, you may already know that memory and registers are only storage that the CPU can directly access. So when CPU works on something such as access some data, execute some code, it can only get those things from a memory or register directly. If those stuff stores on other part, for example the hard disk, so those stuff must be loaded into the main memory, then CPU can get them from the main memory. From the perspective of main memory, it just see a sequence of address combined with operations, either read request or write request. For each combination, the main memory will locate the address first, then apply the operations, either read some data out from this address or write some data into this address. For register, access is quite simple, and also it is very fast. For most of the time, it can be finished within one CPU clock or even less. And also, you may still remember that on the memory hierarchy, register is the most closed one to the CPU. Therefore, it is the most fast one on the memory hierarchy. However, the downside is that it is the most expensive one. On the other hand, main memory access is much slower compared to register access. It can take many cycles, which depends on what kind of a mechanism you want to use for the main memory. For those mechanisms, we will talk about later in this chapter. When the memory access is not fast enough, it can cause stall, this phenomenon. So the CPU just waits there, it cannot do anything because the data or the code which the CPU needed are currently loading from a main memory to register. That is why we need to make the memory access as fast and as efficient as possible. So you may still remember that we can use another mechanism to address this issue, which is cache between main memory and the CPU register. So although it may alleviate this issue to some level, but again, you may want to make the main memory access as fast as possible because the cache miss still exists, which means when the data or the code needed by the CPU for the first time, the CPU still need to load those data or code from main memory to cache and keep a copy on the cache for later convenience. Another important thing is memory protection to ensure the operations can be done on the main memory correctly. For example, the memory space belongs to one process. It can only be accessed by this process itself. Other process cannot access it and also a memory space is used to store the data, you cannot execute this part of a memory. On the other hand, if a space is used to store the code, it could be read-only. You cannot write anything into the memory space. Next, we are going to introduce some basic concepts of memory management. First, let's look at a base and the limit registers, which are used to define the logical address space. On the right side of this slide, it shows us the logical view of a memory. The operating system is always stored at the lowest memory space, which starts from address 0. For the remaining memory space, so we just assign part of it to different processes. For each process, we need to remember which block has been assigned to it. For doing that, we can protect this memory block can be only accessed by this process instead of others. For example, the second process on the figure. To this end, so why we define base and the limit registers. For the base is the starting address of the memory block, which assigned to this process. And for the limit, it is used to remember how large the memory block will be that assigned to this process. Based on these two registers, the CPU can check every memory access in user mode, which means to check whether this memory access is valid or legitimate or not. The figure on the bottom of this slide shows us how to do it. So actually, it can be done in a hardware so that it can be done very efficient and fast. So when CPU wants to access some address, so firstly, it will send this address to the hardware to see whether this address is greater than or equal to base register. If the answer is no, an interruption will be triggered and trapped to operating system to indicate the addressing error. Otherwise, the address will pass the first check and move to the other check, which is checking whether the address is less than the summation of a base plus limit. If yes, CPU can access this memory space and get the content there. Otherwise, the address error will be triggered through an interruption.